right, so this is the next day. Let's continue on with this mold process here. We're going to make the other side of this thing now. The interesting thing is this is the 3D printed part that will have to snap onto that guy right there and be held fairly secure. It also, this is the first part we made. See that little dimple right there? That goes in that square window right there. So that's what this thing has to do. Provides a cavity for silicone injection molding around here. Just prototype stuff. It's going to be done by hand injection basically. But we want to give as good a surface finish as we can. What we've got is face mill, and then we're going to come down with an 1/8 inch flat end mill and do a bunch of work up here. That kind of looks like that. Tons of tiny little tool paths, and then we go into some 3D high-speed area rest roughing and some contouring, 3D high-speed dynamic optirest. And then going to finish it off way deep down in the pocket with more dynamic optirest with a very small end mill, 0.0787 diameter. And that's to do way down inside this pocket, way down in here. So yeah, we'll send some programs and get to work. All right, I've got the center of the work located at 0 in X and Y, and I just sort of dusted this off with my facing end mill and made that, went 5 thou down and made that 0. So now we'll come in and face and do the detail on the very top with the 1/8 end mill. Now we'll go ahead and carve away all that stuff on the outside that we don't need. Alrighty, we got some stuff roughed out. Now we got to go a little deeper down in that pocket. So we're going to switch from our 1/8 bowl end mill to this little guy right here. And I've ground him under on the shank so he can reach down in there pretty good. This is solid carbide, and yeah, let's see what we can do. Alright, here we go. It's got a little bit of, I don't know what this is, coolant maybe splattered on the edge, but we're pretty darn close. I've tested it apart. This edge right here is super sharp, right where my fingernail is, right there. That is super sharp according to his design, but the 3D printed part that fits over this does not have a sharp edge. So what I'm just going to do is come in here and break that edge with that little guy right there. 1/8 45. Okay, I went ahead and did a circular interpolation on the holes with a 1/8 end mill and a 3/16 out here. Next thing we have to do is go ahead and press these pins in there. Yeah, tearing up my mold. That'll be all right. And then this thing basically goes together just like that. You can see that oval detail right there that mates up. And there's a clear, I don't know, like a piece of plastic or glass or something that this will hopefully seal up against, and that becomes the stop for the silicone injection. And then also with this pin and this hole also provides some sort of a, prevention of the flow anyways. This side does not have to be pretty. This is the pretty side. This is purely the inside of this thing, and it's not, none of that is seen from a user standpoint. So basically that guy locks right in there, seems to sit square and down quite well. And then what we've got is I've got two pieces I have to make yet that will go in here, two pieces that will meet in the middle and have this cut out in it with a round basically. And those are quite thin. I'm not sure how I'm going to do that yet, but that'll be the next part. All right, here's the last two pieces for this mold job, and these are small, 2.5 inch squares. What this is, and there's two pieces here that's separated. There's a line, a parting line, right across here in the x-axis. So there's a piece up here and a piece down here. So I was kind of putting this off because this is going to be terrible to try and flatten something off that's this thin. Turns out it's 80 thou thick, and I found some really nice aluminum that's 80 thou thick. So looks like what I need to do is take, I've got two pieces here, and what I'll do is stick them in the Bridgeport and just make a pass here to make a perfectly flat edge that will butt up to one another. Just shove it in there and give it a snug. And just maybe 2 or 3 thou cleanup. I think it cuts better the other direction, so just another thou. And that's a nice surface finish. Okay, this is a looks like a 400 grit stone. So we'll just that's our cut edge right there. So we're just going to just barely break that edge, both sides, and then we'll go all the way around with something a bit coarse to fix all the other edges. Okay, we've got our two pieces mounted on a sacrificial plate. Machined edge here and a machined edge on the plate is lined up as best as I can. Very, very flush. and that will make my line go straight across basically when these things are two pieces and cut out. That's my approximate center, as close as I can get to the actual edge of each plate. It'll be close enough for this, no problem. And what we're going to do is just bore the holes first, and then we'll hand drill into the plate and bolt these guys down, and we can take the clamps off, finish everything, and we'll be done with it. Clean up that spring pad. Okay, holes are drilled and tapped. I just pistol drilled these guys. Now washers have two sides. You know, when they're punched out, they have a sharp side. I don't want that sharp side down. So I don't know if you can see that or not, but that's the sharp side. So yeah, we want to put the soft side, the rounded side down. And these are 1/4 inch clearance holes, ever so slight clearance. And I'm using a 5mm bolt and washer, making sure to put the soft side, the rounded side down. Go ahead and snug these guys. Now I just pistol drilled these. 165 drill, number 19, and then just ran with the drill, just ran the tap down in there, and these tighten down really, really nice. Okay, once you got the bolts in and tight, can release our clamps. Now when we're doing our Mastercam work, we just have to make sure if there's any transitions out of the hole into the outside or across that we clear the bolts, or we break the tools off. So there we go. All right, we just finished up with tidying up this radius right in here. And I used, what did I use? I used 3D high speed equals scallop, a finish pass. And just selected these surfaces and had a bull end mill. You know, it's a 1/8 flat end mill with a 20th out corner radius do all of this work. So one tool did all this work. This is pretty small, you know. So now what I got to do is undercut. You can see here I've got a 45 under here. I've got to undercut this to as close to a knife edge as I can get. So what we're going to use is this guy right here. This says for undercutting. So what we're going to do, I've just programmed a square end mill with the proper diameter, and then for my edges to drive, it's this edge right here all the way around. And basically what's going to happen here is, let's get this up a little. Here we go. Here. And here, she's going to come in with a big lead in and then dive under. And it cuts right to the edge out there. So pretty basic. Saves me the time programming and building a whole tool. It's just not necessary for this application. It's a simple contour, and we'll see how this works out. All right, and there we go. It looks like we've achieved that knife edge. Close enough. So for the last process here, we have to drill the fill hole and then all the vent holes as well. So they're going to be drilled from this side right here. They're going to be drilled from this side, just like this. And what I'm going to do, since the drill is that big for the vents, now the fill is not nearly as bad. The fill is right here. Pretty small. I can't remember what size it is, but they're really small. What I'm going to do is indicate this guy in off the edges, and I'm just going to pilot from the back side, just make a little pilot hole, and then I'll show you the drill press that we use to run this guy. Okay, we got all the holes piloted with this real small Jacob's chuck. And the fill hole I can actually drill through. So we'll go ahead and do that. That's going to be where we're at right now, location wise, which is that big guy right there. So 1.814 in the X and 1016. So there we go. So yeah, we'll chuck this up and just drill through. All right, so here's the micro drill. It's actually pretty nice. It's got a depth stop on it and a speed adjuster. There's a little light down there. And of course you can see how much you're feeding. So the nice rusty surface here helps hold the material. Yeah, we just feed in until we hit air. Gives you an idea how big that is. Okay, so that's a wrap for our little mold. Again, it's going to inject silicone rubber around this little thing, which I don't know what it is. Top secret stuff. 4-piece mold, 2 chunks of Delrin and 2 chunks of aluminum, the little separator plates. Yeah. Hope everybody found that interesting, and more to come. Like, subscribe, and thanks for watching.